Guys, we're doing a video today on momentum and impulse. Um, so this used to be on the old mechanics A-level maths, but it's no longer on the new spec. But it's on the further math spec. Either way, you need to know this for the new A-level AQA physics. So what is momentum? Well, the momentum of body of mass m, which is given with velocity v, is given by m times v. So if the mass is in kilogram and the velocity is in meter per second, then the momentum will be kilogram meter per second. Kilogram meter per second can also be written as kilogram meter per square second per second. As kilogram meter per square second is newtons, kilogram meter per second can be written as newton second. It makes sense. You're timesing the mass with velocity, okay, and using dimensional analysis, you can see that's just going to be newton second. These are both acceptable units for momentum. Find the magnitude of the momentum. A cricket ball of mass 400 gram moving at 18 meter per second. So momentum is mass times velocity. Remember, mass has to be in kilogram, so 400 gram would be 0.4 times 18 meter per second, so it's just going to be 0.4 times 18, which is 7.2 newton second. So pause the video and have a go at part B. So you multiply 5,000, because 5 ton is 5,000 kilogram, times by 12. So that'll give us 60,000 kilogram meter per second. So either newton second or kilogram meter per second is fine. If a constant force F acts for a time t, we define the impulse of the force to be F times t. If a force is measured in Newton and time t second, then the units for impulse are Newton second. An example of impulse would be a cricket bat hitting a ball. So in this case, the time the force is exerted over is small, but if the force is big enough, it will transfer noticeable impulse to the bat. So remember, the acceleration of object is given by A equal to V minus U over T. So F equal to ma. If we replace the A with V minus U over T and multiply by T, and we expand the bracket, we could see the force times time is equal to impulse. So force times time is equal to impulse, so I would equal to mv minus mu. So the impulse is final momentum minus initial momentum. So impulse is change in momentum, and this is the impulse momentum principle. So here's an example of body of mass 2 kg is initially at rest on a smooth horizontal plane. A horizontal force of magnitude 4.5 Newton acts on the body for 6 seconds. We are asked to find the magnitude of the impulse given to the body by the force. We're going to find the final speed of the body. So first of all, impulse is given by force times time. So if we substitute the information, we get impulse equal to 27 Newton second. So now, to find the impulse, we know the formula for impulse is change in momentum. So if we substitute that in, impulse is 27, v we don't know, m is 2, 2 times v minus 2 times 0. The initial velocity was 0. So now we have 13.5 equal to v. So the final speed of the body will be 13.5 meter per second. Okay, so let's have a look at this one. It says ball of mass 0.2 kg hits a vertical wall at a right angle with constant speed of 3.5 meters per second. The ball rebounds from the wall with a speed of 2.5 meters per second. Find the magnitude of the impulse the ball exerts on the wall. So as always in mechanics, we want to draw the diagram. So here's a wall, and it's coming with 3.5 meters per second, and it's rebounding with 2.5 meters per second. And the impulse exerted on the wall will say going this way, and you could also do an impulse exerted on the ball from the wall the other way, and the impulse they equal. So if we use the formula impulse, so we've got the final velocity minus the product with mass with the initial velocity. And be careful with the sign here, because we're talking about velocity. So velocity obviously has a magnitude and direction, it's a vector quantity. So if going to the right is positive, as we've seen here 3.5, then going to the left will be negative. And this is where students get these things mixed up, because they get the signs wrong way. So you guys need to be careful. Follow the sign. So if you work that out, it gives you minus 1.2 Newton second, and we know the impulse could go either way, and impulse always written as a positive, so impulse is 1.2 Newton second. Alright guys, so now we're going to look at conservation or principle of conservation of momentum. So by Newton's third law, when two bodies collide, they exert equal and opposite forces on each other. The object will also be in contact for the same length of time, so the impulse exerted by each will be equal but opposite in direction. Therefore, these changes in momentum cancel each other out. The overall momentum is unchanged. And this process is called the principle of conservation of momentum. So momentum before equal to momentum after. So we could say total momentum before impact equal total momentum after impact. So if we have these two blocks or spheres, and we call one M1, the other one M2. So before collision and then after collision. So it's important for both of them you write down, or when you draw the diagram, you put the velocity before and the velocity after. So what we could say is the total momentum before the impact is equal to total momentum after impact by writing it in this formula here. So there you go, you got momentum here, m1u1 plus m2u2 equal to momentum after m1v1 plus m2v2. Now this formula is going to be very important. This is the principle of conservation of momentum formula. Now what you'll notice in some textbook, in physics textbook, rather than using m1 u1, they probably use ma ua mb ub. It's the same thing. I hope you guys don't get too confused with this. Okay, so when we solve problems involving this principle, first we can draw the diagram, label the velocities before and after the impact with the relevant directions, and then draw an impulse on where necessary and choose a positive direction. This is a very important point here. So if you're going to the right as the positive, anything going to the left will be negative in terms of velocity. So don't get them mixed up. So have a read of this question. Okay, so here we got a particle of mass 2 kg moving with speed of 3 meters per second on a smooth horizontal plane. A particle Q of mass 3 kg is at rest on the plane. Particle P collides with Q. After the collision, Q moves away with a speed of 2 1/3 meters per second. We are asked to find the speed and the direction of the motion of P after the collision, the magnitude of the impulse received by P and by Q on the collision. So we're going to draw the diagram. So here's our P and Q. Before collision, P is moving with 3 meters per second, Q is at rest, and we could just use the direction as right and put 0, makes no difference. And then underneath we could do the after collision, and make sure you be careful with your signs. So we're saying P going same direction, v meters per second, and Q going with 2 1/3 meters per second. Remember, it said Q moves away, so you can't possibly go to the left, it has to go to the right. Okay, so now we're gonna just use this formula. Make sure you be careful with your signs. So 2 times 3 plus 3 times 0 equals 2 times v plus 3 times 2 1/3. So you work this out. Okay, so if we calculate for v, we get minus a half. Now this is interesting, the negative. So the direction of P is reversed by the collision and it moves off at 0.5 meters per second. Make sure you write this sentence down at the end if you get negative. Don't leave it for the examiner to take a guess what you mean. So it's changed direction to state that information. Alright, so now we're going to find the magnitude of the impulse received by P and by Q in the collision. So we substitute into impulse formula. Take the direction of impulse on P as to be positive. So look at the diagram, it's all been highlighted in red. So if we follow the direction, going to the right as positive, then going to the left will be negative, and so on. So you need to be very careful how you solve this. So you work this out, and that gives us impulse of 7 Newton second. And let's work out the impulse on Q. So you guys pause the video and do one for Q. Okay, so what you notice is if you work out the impulse for Q, it should be exactly the same. Okay, and we get 7. So if you take the directional impulse on Q as the positive direction and you calculate this, because they are both experiencing the same impulse on one another, that's why it should be 7 Newton second. Okay, so pause the video and you guys have got this question here. Okay, so we could expect to do this where the strings are connected or two particles connected by a string. So if we have two particles A and B of mass 8 kg and 2 kg respectively, and connected by a light inextensible string, the particle is at rest on a smooth horizontal plane with the string slack. Particle P is projected towards away from Q with a speed of 4 meters per second. So same as before, if you draw the diagram, so before collision, A is pulling B. So we'll just draw a diagram something like this. After collision, because the string becomes taut, they both have the same velocity. They have a common velocity. It's almost like they coalesce. So this is very important here. So now we all have impulse going towards one another because the string is taut. Then if we plug into the formula, so momentum before 2 times 0 plus 8 times 4 equal to 2 times v plus 8 times v. Now you could just simplify the right hand side, that gives you 10v. On the left hand side you got 32. So v is equal to 3.2 meters per second. Sorry, so there's a slight error on the wording here. It's talking about A and B rather than P and Q. That's a small changes. Okay, so now to work out the magnitude of impulse, if you just use the impulse formula, we know what the V is now. We could use this, you substitute that in, and it gives the impulse of 6.4 Newton second. This is all we need to do. The impulse in the opposite direction will be the same. And we saw that in the last example where we actually worked out both of them. And that's always the same for all collision. Okay, here's another question. So you guys pause the video and have a go at this question. Okay, so before collision, after collision, so if we use the impulse formula for P, make sure you be careful which way you're resolving. Impulse was given, so we could work out what the velocity was, and that's 0.5 meters per second. Now for particle Q, impulse, you substitute that in, and you expand the bracket and you do the working out, we get minus 2.5. Well, that's interesting. The negative is telling us is actually didn't go the other way. It means it was actually going to the left. If the answer is negative, the direction will be on the opposite in the diagram. So we can see in the diagram 0.25 meters per second. Okay, here's an exam question. So you guys pause the video and have a go at this. Welcome back. So the answer to part A is V equal to 5U, opposite direction. We use the formula for principle of conservation of momentum. And for part B, we could use the impulse formula and we'll get 10 mu. Here's another exam question, so pause the video and you guys have a go at this. Welcome back. So for part A, you should get this, and you could leave it in that form. And since the direction of motion reverse, k is greater than 2, so v is greater than 2. And for part B, using the conservation of the principal formula here, we get 7 mu.